Sounds okay. Okay. So welcome everyone. Today, what I'll be doing is covering a workshop that I ran in person a few weeks ago. So it's great if you weren't able to attend that one. And we're going to be talking about what is AI. So it'll be a very, very basic overview and an introduction of what is AI. So my name is Omar. I'm doing a PhD at the University of Leeds. My research looks at using AI in healthcare and have a background in computer science. So today, the idea is that we'd look at what is AI and how does it work? What is machine learning? How can we train AI models? What kind of ethics do we have to consider when it comes to AI? And how could we use it to solve everyday challenges? So as a starter, we see AI everywhere in our lives, but you may not realize it. So when you unlock your phone and you're using any kind of facial recognition software, there's AI built into that, into self-driving cars and sensors, home assistants, robotics, including in Amazon warehouses, on Google, and of course the one that most people would be most familiar with, and that's ChatGPT, right? But AI is not just these chatbots that you can use that you write questions to. It's actually really powerful. And it can be used for a lot of really good things, right? So this is an AI application that was developed by Google. And essentially for a long period of time, when it came to how many proteins we could develop, right? So looking at the different sequences of amino acids, right? It took us decades and we could barely get 150,000. And with AI, we were able to solve, hundreds of millions in just a few months. And AI is really powerful. What I thought I'd like you to do first is why don't you think about and put in the chat just where do you see some tools, in your daily life that you think use AI? And think about what kind of data would be required. So this is a very key word that we use, a very important word that we use when it comes to AI, and that's information, right? So when you're using a chatbot, that might just be text. So just think about what kind of tools do you use and do you see? And what kind of data will be required? And what do you think are some of the pros and cons of some of these tools? Email always suggesting replies. Yeah, it can save a lot of time. If anybody's got the latest iPhones or any of the Apple devices, you might have seen that it's summarizing your notifications. Alexa, voice and personal data about the user, of course. And there's a lot of fears with that. How you may not realize it, right? But if it's storing all of that data about you, how you speak, and the way you sound, maybe it could be used by some hackers, who get access to that data, and they could use it to get, a clone that sounds just like you, and could be used to open bank accounts, etc. Smart keyboard, over the phone banking using voice recognition. Yep, any banks offer that now. So that there's two really difficult questions to answer, and that's will AI replace humans? And is it okay to use AI to do your work for you? And this is something that AI experts of even now they will continue to debate whether or not AI will replace humans. And what do people say when it comes to doing work? Because some people are all for it, write as much code for you, write all your work, all your reports. And some people are on the complete opposite spectrum. So I wanted to see in the chat, what are some of your thoughts? AI won't replace humans. Why? Why would you think that? And anyone, feel free to turn on your mic. I believe cameras are disabled, but you can speak if it's easier. But it is recorded, so if you wouldn't like your voice to be heard, you can just use the text. AI is a tool only. I don't think it would replace humans, but it should be allowed to do work, as that saves plenty of time, especially for people that don't know how to code. Yeah, that's an excellent use case. I'm definitely on that kind of a school of thought where for people who don't know how to code or program, it's an incredible tool just to get it to do stuff for you. Obviously, it's difficult because sometimes it makes mistakes and you can't solve it. And I would say it's different for people who are, let's say, studying computer science, because I think for them it's an important skill to learn. I think they would lack the originality that humans have. Yeah, so this is a really interesting thing. The creativity that humans have, the way that our brains work, is very different. That is very different to how AI works, right? Because AI will see it. It doesn't necessarily come up with anything new. They work within the constraints set by humans. They might replace certain jobs, but not humans as a whole. It should help help us along with our work. Some great ideas. So, you can look at what does AI mean, right? And it will say the simulation of human intelligence by software coded heuristics, but I don't really like these kinds of definitions. What I prefer is, what ChatGPT could come up with, right? It's when computers or machines are programmed to think, learn, and solve problems like humans. They can recognize patterns, make decisions, and even talk or play games, but they don't have feelings or real understanding like people do. This is really important, right? So as an example, we could use AI to detect, say, tumors in scans of a patient, right? So the idea would be that a person can go into hospital, can get a scan taken of them, and before it goes to somebody who then has to interpret and look at the scan to determine, whether there's anything there visible at all, the AI would just take this image, look at it, detect if there is anything inside, and tell the healthcare professional, the clinician, if there is anything there. But like, how does that work? And so what it does is it's very good at solving very specific tasks that you have told it to do. So what we would do is we would give it maybe thousands of images of scans, and many of them would have to have something like a tumor inside it, something that we want to detect, and many of them would have to have something, or we would not have to have anything, right? They need to be completely healthy, and that way we give all of these images to a model, and we'll see how it can learn to then distinguish whether or not there is something there. And the way that it works is using machine learning. So this is where we use algorithms which can learn patterns in the data to make predictions. So if we look at lots of images and there's, it looks like when there is something that's a little bit larger, we see that it's often, as a person has said that it's a tumor, then that's the kind of pattern that an AI would learn. Similarly, if there was just bone and it's never ever classified as anything, then it would again not detect that as anything because it's learned a pattern that it's not a tumor. It's not anything dangerous. And so what AI will use is large amounts of data, right? And that extends to things like text, audio, voice, anything that we can capture and put onto a computer. And humans will have to label some of that data with what we want our models to predict. So as an example, when we had this scan, a person would have to go there and draw a box around anything that looks dangerous, something that they want to detect. And then they'll have to also write. So they'll have to write somewhere that will say, okay, there is this type of tumor, and they've already labeled where it is. And they have to do that for thousands and thousands of images. So it's very, very time consuming. And then these AI models are really good at picking out certain patterns. So if you took numbers, for example, maybe an AI could learn that, like, for a number 2, that there's a certain pattern, maybe like a little bit of a curve and then a straight line. Maybe for a 3, we see that there's 2 curves that are joined together. And these kinds of patterns that build up the shape of these numbers, some things that we know straight away when we look at these numbers, that the AI is trying to learn these different patterns and the structures of how does something appear on on an image, and similarly in text. And so then when you give it a new piece of data, it will use all of those patterns it's learned so that when you give it a new example, it will then be able to predict, which one it is, right, with the highest probabilities, which one of the options have the highest chance of, that image containing that object. So as an example, let's say we have an image of a dog, or we're trying to build a model that's able to, let's say, classify, which means it's able to predict when there is an image of a dog. And for that, we're going to need to collect lots of data of dogs, and we'll need to then label it. So we'll need to draw a box around the dog to tell, so that our model will be able to have enough information to know that, okay, when there is an image of a dog, where is the dog inside that image? And then maybe we tell it some extra information, right? So we tell it where its mouth is, its ear, its nose, its face, and these kinds of things that maybe we use because we know that certain of these features, right, the physical features of this animal leads us to believe it's a dog. And other dogs will have very similar features. So then when we give it to a model, it will essentially take this image and it will run some things on it. And this is something that we can cover in workshop 3. So this is a neural network, and we'll look at how do these actually work. And essentially, when you give it a new picture, right? So in this case, we've given it another dog. It will be able to predict, right? And it will classify that, okay, there is a dog, and here is where it is in this image. But the problem with AI is that just because it works on some images that you've given it at the beginning, right? So you may be working on a project or you have lots of data right now, but if your data isn't representative of your population, right? So what that means is there's a whole number of how many dogs there are out there, but you would never be able to take a picture and label every single one. You can only ever get a certain number of them. But by using the ones that you've got, is it possible that when you give it another picture, it's able to detect it? And also that when you give it a picture of something that's not a dog, so say a cat, it doesn't make a mistake in detecting it as a dog and instead detects it as a cat. So what I'd like all of us to do now, and I'll be doing this with you all too, is we're going to look at a little bit of a hands-on activity on how we can actually train an AI model. So there's this website by Google where they have a very nice online website which you can use to train different types of AI models, obviously with a certain small amount of data. So if you go on Google and you type in teachable machine, you'll be able to get to an interface that looks something like this. And I think from here now, I will begin to share my screen so that we can see it all together. So we'll look something like this. You can click Get Started. We can do an image project. We can just do a normal standard image model. And you'll get something that looks like this. And if anybody has any questions, you can just put it into the chat at any stage. The next thing that we want to do is somewhere on our computer, we're going to want to make some folders. So the first folder that we'll create will be called train. And this folder will contain images that we are going to use to give to the model, and it will learn from whatever images we've given it in this folder. And we'll have another folder called test, and this will just be there for later. We want to test our model to see how well would it work on other kinds of data. Inside this train folder, we want to be able to, let's say, detect the difference between pens and pencils. And you can pick whatever two different kinds of objects you would like, whatever you would like. And I believe Teachable Machine gives access to maybe 4 classes. So what you can do is create a folder for each of the classes that you're considering. So I will just do pen and pencil, because they're objects that look similar, but we know the difference. And we're going to see if the AI can tell the difference between what's a pen and what's a pencil. if that's fine, if I just get in the chat, if that was easy to follow for everyone, if it's okay for now, then we can move on. Okay. So now, go back to sharing my screen. So the next step is that we'll go on the internet and we'll just look at pictures of different objects, right? So I've chosen pen and pencil. Be creative, pick whatever you would like. What you want to do is you just want to save the image, save these images, right? So I'm just going to click Save Image, and I'm going to put it into the file in my training folder inside the pen. I'm just going to call it Pen 1. And now what I'll do is go to the next image. And again, I'll do the same thing, save image, and I'll call it Pen 2. And you want to be able to get a decent number of examples. The more examples you use, the better the model can be. If you use a small number of images, then obviously the model will be able to learn how different pens, maybe from different brands or different sizes and different types of pens would look like. For example, a fountain pen, it looks very different from a normal kind of pen. So maybe we'd want that kind of image. And now I'm just going to, and maybe you'd want to get at least 10, but for now I'll just skip to pencils. And I'm just going to start saving images of these pencils too in the pencil folder. And I'll call it Pencil 1. And I'll save another one called Pencil 2, etc. Should be quite easy because we aren't doing anything extra. We just, this kind of model, because we aren't exactly telling it where the object is inside the image, it will just be able to tell us which object is in the image, not exactly where. Because there's two different kinds of problems when we have images. One is, what is in the image, and the second is, can you actually find it specifically? Could you draw a box around it, to point it out to somebody else? Okay. So I've got 6 of each, I think, now. And what I'm going to do is now I'm going to save one test image for each. So I've got one test image of a pencil. Now I'm going to get one test image of a pen. That might not be correct file type. And so now, I'll go back to the PowerPoint if we need to see these stages again. On Teachable Machine now, I can put the different classes, right? So in my example, I'm using pens and pencils. You could use whatever else. And now we can upload. So I can go into the images that I got of pens, and I can place them all in the folder here. So if I select all of, oh, so it looks like WebP files won't work. So the way to get around that is if you type in file type, so I can put this into the chat too. You can use this to get specific images that are JPEGs. Maybe I can just change it directly here. Yes, this will work too. So the reason for this is that we have different file types for different images, and this kind, the WebP, seems like it doesn't want to work on Teachable Machine. So I'll just quickly change all of them. And now just the test to make sure it's fine. Okay, so now if I go back, yes, and now I can select all the images of my pens. And you'll see they get loaded up here. 6 is a very small number. Ideally, you'd want 10, 20, something like that. And the same thing for the pencil. I can add all the different pencils. And at this stage, what I've done, and this is what you would do in any kind of machine learning project, even the very, very largest ones, like when you're training ChatGPT, you need to collect data and you need to label it. So our form of labeling was just to tell it which object was which. Obviously, you can go into more detail for that. The next step would then be to train a model. And we'll look at specific models later on in different workshops. But for now, we'll just pretend like this will just train a AI model for us. You can see here now, it's going to start the training process. We're not going to use the camera because I want to check with actual images. So I'm going to check File, and I'm going to select the test image, so the test pen. So I've given it a test image. What it is, I changed it from webcam to file. And you see when I give it an image of a pen now, it tells me that what it sees here, if you gave it the options of either there's a pencil or a pencil in the image, there's a 99% chance that this is a pen, which is really good. And I can select another pen. And this one tells me it's 97%, a little bit less confident, but really anything above 90% is extremely confident. And I can give it the pencil. And we can see that it gives me 100% for the pencil, right? Obviously, there's a lot of things here that have been made simplified. But if you have a good set of data and you have a large number of images here, which are representative of the kinds of images you'd see, because of course there are so many images here, it's difficult to get everything. But if I gave it a picture of a pen that looks anything similar to what I've given in the training data, it will always give us extremely high probabilities for predicting the correct image. But if you gave it something that maybe we haven't seen something too similar before in the test data, what you may see is that it doesn't perform as well. Need to change that. I mean, in this case, it's fine. I will now go back to the PowerPoint, and I would really encourage that to play around with a teachable machine in your own time. Try and give it different types of images and see what you're able to experiment with, and when does it not perform so well. And I'm going to go back to the PowerPoint. This is where we left. And yes, the idea whenever we do anything with images, you create your training and test folders for each of your classes inside that training folder, and then you just populate it with example images that you're able to find, and you get some test images too that you could test on later. And that's really how simple it is to train a basic AI model. Maybe I could get some feedback in the chat if anyone is able to try anything alongside. What did they experiment with, and what kind of results were they able to get? And if you weren't able to get enough images, maybe just what were you trying to do? I'm not sure they're jumping the gun. Can you use AI models to train other models? Yes, you can. So we'll be running a workshop in a couple of weeks. We'll be looking at one of the biggest new large language models called DeepSeek. And what they were able to do is they were able to train their model using OpenAI's ChatGPT's models, and other large language models out there, and it was able to far exceed the performance of all of those predecessors, all of the other models that were out there. But the problem is that in AI, there's a principle called garbage in, garbage out. So the idea is that if you give a model really bad information, right? So if I labeled all my cats as dogs and all the dogs as cats, the model doesn't know what is a cat and what is a dog. It just knows, that these things have been called this, a dog, and these things have been called a cat. To us, we know it's made a mistake, but it won't realize it. It will think that it's doing a good job. And so what you have in things like with ChatGPT is people are using it to make, get responses, uploading them onto the internet, and now that's being used again in more training data. So they're training models from the output of other models. And so in that case, they're doing it, but it may not result in the best performance because let's say those outputs had mistakes. Now the model, this new one, is learning from those mistakes. And that's what we're seeing a lot when it comes to things like coding, because so much code now is written by AI that the generated code now has to be really accurate because it doesn't want to make it, you wouldn't want it to keep the mistakes that people are putting on the internet, on the output of those other models. So in person, usually I would have gone round and we would have spent a lot longer on this. But the recording is available, so you'll be able to watch back and see exactly what I was doing, and you can try it for yourself later. So I think at this point I can just move on. So in the learning objectives, one of the things I had mentioned was to consider the ethical considerations of AI. And this is something that a lot of people have debated about, and there's lots of problems out there when it comes to people's, let's say, personal ethics, or what certain countries have as their beliefs what things should be like, right? So the EU has a very, very different stance than the UK does, and they both have very different stances to what America does, what they believe, and all of them are completely different from what China believes, etc. And that's just how it is. But there are certain things which are very clear, and that certain models will have these biases in them. And regardless of what people have in their policy, when you look at something like this, where you have an information about the prior offences and here the subsequent offences of this man here, you can see that he had 2 armed robberies, 1 attempted armed robbery, and then later had an offence of 1 grand theft. And you have another man who had 4 juvenile misdemeanors as his prior offences and didn't have any subsequent offences. You can see that the AI model was giving these kinds of risks, right? So like it gave this person a risk of 3, and this was a woman, this woman a risk of 8. And obviously, if you were just to look at this information sheet, you would assume always that the one on the left doesn't matter whether it's a man or a woman, etc., right? This person has clearly performed more crimes and would expect to have a much higher risk than somebody who has not had as serious offences or as many offences. And it happened time and time again, right? So this was an example of model showing that basically this model, what it had learned was that if a person had a darker skin complexion, right, if you were black, all of a sudden it meant that you had a higher risk score for reoffencing, for committing a crime after being released from prison. And this is a really big problem because essentially, not only are you keeping in potentially certain people for longer than they need to be, but you're letting people out who potentially and did, in fact, have subsequent offenses. And this is a really big problem with AI, and it's very, very biased because AI uses that data that we gave it. And if our data is biased itself, or if the people that are making it are biased, then the models will be biased because the models just make the correct prediction. So for the model, let's say in this case, it assumed that a person's skin complexion gave it the most, importance, that was the most important factor in determining somebody's risk of reoffending, when in fact what they should have done is not even included it. And subsequent studies have come out, and what they've done is they've tried to remove this element of ethnicity, but they all have the same problem again because there are different ways of predicting whether or not what a person's ethnicity is based on the kind of socio-demographic, where they live, where they went to school, etc. These are really big problems, right? And it's not just small kinds of models, right? Huge companies, right, notoriously had extremely low performance on their facial recognition technologies for darker females, right? And this was very simply because they didn't have enough data on the group of people. And so what they should have done was two things, right? One would have been at least to explain that, like, look, the model will perform worse because we didn't have enough training data. And the second would be that you try to encourage these groups, these minority groups, to come forward and give more of that data. So, for example, in healthcare, we have huge data sets, but it's filled with just the same type of middle-aged white men, the biobank data set, right, which is known to just have a very consistent demographic, and so it's not usable on anybody who's from a different age group, let alone a different ethnicity and where they may live. And these are things that we have to consider when we make these models, is that when you give it the data, and again, it's the most important thing is the data, is that you try to give it in the most unbiased way. And that when you test your models, that you test it on these different groups, let's say, and you may have different groups to make sure that it performs well enough on everything. And if you can't, if it does perform worse, then you report it and you explain why do you think that is. Right, and there's many ethical implications, right? So we discussed a little bit earlier about the job displacement, and certain models are definitely like the chatbots. They are cheaper to run than the minimum wage of many countries. So certain jobs could most definitely, somebody could decide that, what, I want to try and use these instead. We know call centers, for example, they are, there are usually many employees there that will be there to answer the phone and to do work on the databases. And they are extremely important for people because they are there to deal with the issues that we have when we have, an issue with our order or our service with a company. And regardless of whether it's farmed out to other countries, right, third world countries, those people may and will have lost their jobs because there are certain AI tools now which can do a lot of that work for them. And we've talked about bias and discrimination. Privacy is also a huge problem because maybe for an individual, you decide, you know what, you don't really care whether your data is out there on the internet. But let's say a person is somebody who has health problems, and that data then gets into the hands of an insurance company. And maybe now that person either charges them a lot more for their insurance or just refuses to deny it to them, or maybe a job itself, because that type of person, he or she, would directly be impacted if people knew about their situation, because those companies would recognize that they have higher risk and they're more likely to maybe make a claim. So yes, it doesn't concern many of us, but the people that it does concern, it is very important that people whose data is necessary, who may have data which is more sensitive than others due to these factors, that it should be protected, perhaps more so than others. Another problem is with the black box nature of AI. So what I showed earlier was that when you have a model here where you're able to take images and features and you're able to give predictions. And same within Teachable Machine, when we train the model, it's very difficult sometimes to really know what exactly is going on, right? What is it actually doing? So a lot of people may think that things like ChatGPT and these large language models that they actually think. And sometimes they show their, quote, chain of thought, this idea that it shows you what is it thinking and what is it doing. But these models don't think. They are really good at statistics. They're really good at predicting what the next character or like word would be in the sentence, right? And you combine sentences and you can make paragraphs and you can make reports, etc. And they have different ways of doing certain things better, but they do have this black box nature where we don't actually know what's going on inside these models. And some of them are a little bit easier to understand, but we know that they're not as powerful. The most powerful ones have this characteristic. And so some researchers, they try to make sure that we try to explain our model as much as we can, right? So that when you have an instance like this, when a person sees this model has detected something in the scan, that the clinician has some idea, like why did it choose to pick that? Because if the patient comes with this, they've taken their scan, gone to a model online, gone to the clinician being like, oh look, this scan says I have something or that I don't have something. Well, how will they be able to respond if we don't know how these models work? Another thing is with trust, because you give money and data to these companies and you don't know exactly what may happen and what they may do with them. Over reliance is a really big problem. So in this current, these last 3 years since ChatGPT has been out and people have been using them, I've noticed it, with my students, that they are not developing certain skills that, say, I developed or that other students had developed because they had to do everything by themselves. A lot of students are now just using it to make their coursework, to write all of these different things for them. And people can't detect it, or there's not enough proof to detect it, so they'll get away with it. And that's exactly the way that they think about it, is getting away with it. And they don't realize the implication that it has on your skills, these critical skills that you won't be able to develop properly, right? So you are not able to critically analyze a news article or a video or reading a paper, a scientific paper. And these are problems that we see is just getting worse and worse. And so this is a really key thing, right? Is that you can't become too over reliant. If let's say you take a doctor, and the doctor, whenever he gets or she gets something that's been detected, and just sticks to whatever the model says, and never uses their own intuition, maybe their own experience and what they've seen, and they just tell you what they've seen from the scan. These models will never be 100% accurate, right? And maybe the human won't be 100% accurate either, but maybe they will be able to detect when there is certain problems with these predictions. Or even worse, what happens if these models no longer work? If you are in a place where, let's say, there's no internet or the model doesn't work right now or something's happened to it, and now not only have you reduced your skill and you haven't got the expertise anymore to be able to interpret with this scan and what's going on, because of your over reliance on these models. Responsibility is a big one, and that's mainly on the developers and the people who have certain positions of power that can make change in policy, in government, etc. We know that the UK has released a lot of talks and legislation about what they want to be able to do with AI in the next decade, and it looks promising, but it can have negative consequences. So they want to develop these AI growth zones, which will have these huge data centers, which will be using so much power that they'll be taking water from reservoirs, which is used for clean water reservoirs, which is used for people's drinking water and what they use for in their homes. And that water will now be going to these data centers, and they'll need to figure out a way to what will those people do when these data centers are taking all of this water for the cooling purposes, right? To keep these machines cool when they run at these high amounts of power. And the last one, it's also politics, not just warfare, but it's this idea that, AI is extremely powerful. And we'll look at that in subsequent workshops, that how we can train models very quickly, very easily to do really complicated tasks. And if you've got enough money, you would be able to very easily develop models that could give you a huge competitive advantage. And sometimes it's in very scary ways. So we know that there are technologies out there that can do a lot of damage in a very short amount of time by using AI, face recognition technology, and other types of detection technologies. And again, it's just an ethical consideration, something that we should be thinking about. So, on a more positive note, we know that AI is really powerful and that it can solve a lot of different problems. But I just want you to think about, your own school, or your workplace, or community. What are the potential problems that you see that maybe AI could solve? So I've given two examples as just an example for like waste management and education. With waste management, maybe it's this idea that, imagine you could um, have an AI that developed on cameras that was able to see when people are littering, let's say, and something like that could be used to deter people from littering, something that is genuinely going to be a good thing for society. When we have reduced littering, our streets will be cleaner, etc. So just in the chat, or you can speak out if you have any ideas, any ways that you would consider AI could be useful. Writing discharge letters. Yeah, so I'm aware that this is something that is a very tiring and tedious task and very repetitive, and it doesn't take much effort to do it. And yes, if our clinicians, if the doctors didn't have to do this, they could spend more time with patients or just on their own development, etc., and not have to do these very boring administrative tasks. AI recipe maker based on what you have. Yeah, so something like this, they exist, and they are really interesting. You give it what you have, and it can come up with kinds of recipes from the ingredients that you have, and similar menial administrative tasks like referrals and note taking. Interesting. And testing code. Yeah. So writing tests for code it's one of the most, tedious, boring tasks that we do, but we have to do it because we never want to ever accidentally make some code that then breaks it. I don't know how many of you may be aware about the CrowdStrike incident. I believe it was CrowdStrike that happened a few months ago now in September, where one of the antivirus companies released a software without testing it properly, and it caused, I can't remember exactly what the damages were in the end, but millions of devices went offline and they had to be fixed manually. And just if we used AI to make sure that that code was tested and make sure it all worked before it was deployed, would be great. And dictation software. A lot of good ideas. This was a very basic introduction. And the next two workshops were a lot more technical, but obviously still based at very at beginners, people who don't know much about computer science or coding. And we'll go through some direct coding notebooks. So we're able to go through, see roughly how we can write code to do some AI. And hope you find it really interesting. So I have a feedback form, and we have our WhatsApp community chat, just a little bit easier to give any announcements. And I know that not everybody is a student or staff member at the University of Leeds. And if you would like to, this might be easier to keep up to date with things. And you could share it to others, anybody else that you know is also interested. And this recording eventually will be made available. There is a repository here. So this is just a link where I put the files for the different workshops, and you can go ahead and you can always refer back to these slides and the different notebooks that we'll have. And of course, any questions, you can always contact me through LinkedIn or my email address. Need to sign in for GitHub. So I think when you go on to, oh, I see. Okay, I will make sure that is fixed. It's not AI. Okay, yes, the link is incorrect. I will change that. Thank you. But to download the repository, you won't need to sign in. The link should be public, and you can just download it directly onto your computer, all the different files. And if that's not suitable, there is a website which contains the information too. I'll put it into the chat now. Will the feedback form be in the WhatsApp group? Yes, I can put the feedback form there as well. I think we'll end here. Next week, we'll be looking at building a machine learning pipeline. So I'll cover obviously what does that even mean and why is it important. Thank you all for joining. I will end the meeting now, and I will put the feedback form in the chat. And I'll see you all next week. Thank you.